So I thought I would take time to give an explanation of the practice final. Hopefully it will help some of you do better on it. So the first question, which is a substance? A substance is something with only one identity. It has to be pure. So something that's pure, one identity, would be either an element or a compound. So with these choices, salt water contains salt and it contains water. So that's two different things, so it's not a substance. Iron is an element, and so it falls into the correct category of having a single identity. Okay, a substance in which all of the atoms are alike. Now we're looking at an element. So if you have all the atoms alike, we call that an element. So it's a substance, but it has sodium and oxygen in it. Hydrogen has only hydrogen, and sodium chloride has sodium and chlorine, so the atoms are alike in hydrogen. So you're looking for an element. So that means element. Now, if the exact combinations of the elements are all the same, number 3, then we're looking at, example would be H2O. H2O water always has 2 H's and 1 O. Sodium chloride always has 1 sodium and 1 chlorine. Aluminum sulfate always has 2 aluminums and 3 sulfates. The combinations are always the same. Those are called compounds. The diatomic substance, now remember diatomic means 2 atoms. So that's 2 atoms, diatomic. Nitrogen has 2 of the same atoms. That would be N2, like that. So if it's diatomic, it means 2 atoms. If it's an element, a diatomic element, the atoms would be the same element. You can have a diatomic compound where the atoms are different, like HCl is a compound, but that would not be an element, that's a compound. All right, which is a solution? A solution is evenly mixed. So the thing that on this list that's most evenly mixed would be salt water. Fog is close, but you might remember back at the beginning of the year we were talking about things called colloids. Fog is one of those. It's almost homogeneous, but not quite. Solutions are homogeneous mixtures. Okay, if you can separate a sample of matter, this is like the salt lab we did back at the beginning of the year, the sand and the salt and the iron. If you can separate it without doing a chemical reaction, then that matter was only a mixture. The only way to break apart a compound is by doing a chemical reaction, but you can separate a mixture by boiling or using a magnet, filtering. All those things are the things that we did to separate a mixture back at the beginning of the year in our first big lab. Moving forward. Okay, elements are something with only one kind of atom. And that's a particle, one kind of atom. So if you look at our pictures up here, this certainly fits the category of a substance, or excuse me, of an element. So does that one, because everything's just alike. This one would be an element because every atom is the same. This one you could argue for because it's a mixture of elements, but that's an element, that's an element, that's an element, that's an element. So it's a mixture of elements. Pardon me just a second. There's only one in there, though. Okay, so only elements, one kind of atom could have been A, C, F. Those are your best answers, but you could also make an argument for G. It is a mixture, but every particle, that's an element, that's an element. So it's a mixture, but it's a mixture of elements. Okay, heterogeneous mixture of elements and compounds, that has to be box B, and that's the only one that fits. That's an element, but that's a compound. So that's box B. Only compounds, well, that's lots of them fit that. Because this is elements, that's an elements and compounds, that's element, but that's only compounds because those 4, 5 particles are all the same. only compounds. This is not a compound because these atoms are the same. It's an element. But this is a compound. This box contains a mixture of compounds, but still it only has compounds in it. So you could have said D, you could have said E, you could have said F, you could have said H, you could have said I. So there's lots of possible answers. Oh, not F, I'm sorry. Scratch F. So D, E, H, I would be compounds. A mixture, that's where you have different things in the same container, but they're not chemically connected. So a mixture would be G, because there's two different things there. A mixture would be I, because there's two different kinds of compounds. And a mixture would be box B. There's two different kinds of things there, elements and compounds. Okay, box number, a pure substance. A pure substance would be anything that has only single identities in it. So anything that wasn't a mixture would be pure. So on this little chart, that's pure, 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 and pure. So it's everything except for those three. So you could have said A, C, D, E, F, H. Any of those would have been fine. And then 5 molecules, you're looking to, molecules are groups of atoms that are chemically bonded, and they can either be elements or compounds, but they have to be chemically bonded. So this is a box of 5 molecules, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. That one has 5, that one has 5, and that's all of them. These are not molecules, and this doesn't have 5 molecules. So the best answers would be D, E, F, D or E or F, or H or I. All right, moving on. Okay, nucleons. Nucleons are the protons and neutrons. If you remember back to our understanding of the atom, in the middle there's a nucleus, and in that nucleus there are protons and neutrons. Okay, the protons and neutrons make up all the mass, and since they're in the nucleus, they're called nucleons. All right, so protons and neutrons in carbon-14. This number is the mass, so that would be C. 14 protons and neutrons. So again, I'm not sure if I jumped off screen. There's a little dot right here. I'll draw that again. A little dot. The protons and neutrons are in that little dot. That's the nucleus. The electrons move around the nucleus. Okay, nucleons are the protons and neutrons. They're in the nucleus. 14, they have mass. 14 is the mass number. So that number of nuclei is 14. The protons for carbon is 6. And here's how you know. You go to the periodic table and the number right there is a 6. That's how many protons it has. That number can't change. If that number changes, then it's not carbon anymore. Number of neutrons, you know that the protons plus the neutrons is the mass. And we know that 14 was our number of nucleons. And we just said there's 6 protons, so that N has to be 8. So if you subtract the protons from the mass number, you will get the neutrons. Okay, the smallest unique, this is supposed to be unique particle. There's a little typo there. Okay. Unique means having a definite identity that is different from something else like it. So that would be an atom. Protons and neutrons and electrons are all the same no matter what atom they're in, but the number of protons determines what the atom is. So the smallest unique part of an element is an atom. Okay, the particle that gives the nucleus the charge, remember we have this little charge and mass chart. I'll make that little chart for you. So if we have charge and mass, and you had protons and neutrons and electrons. The protons have a positive charge, neutrons have 0 charge, electrons are negative. Protons have a mass of 1, neutrons have a mass of 1, electrons have so little mass that we say that it is 0. So since in the nucleus we have the protons give the nucleus a charge, so that would be C. Isotopes go back to things that can change in the atom. There are two things that can change. Neutrons and electrons can change and not change the identity of the atom. Protons, if they change the identity, like I said a minute ago. So the neutrons, if they change, that's going to change the mass. If the electrons change, that's going to change the charge. So an isotope is what we use to talk about varying. It's a word that means varying mass. So to do that, you change the neutrons. So the answer to that question, isotope is a specific element with a varying number of neutrons so that the mass changes. Okay, the electron cloud, this one I had the same answer twice, both correct and incorrect. The electron cloud is negative and has a very low density because electrons are negative. So it's not what I intended to put there for a choice, but we'll have to live with it. So the correct answer is there. It's just there twice. It could be A or D. Okay, the mass of the atom is contained in a pinpoint center called the nucleus. We just said that was true up here. Remember that picture? So that's true. Atoms of the same element, what do we say has to stay the same or else the identity changes? That's the number of protons. Protons are defined as the atomic number. So the answer is A. All right, which of the subatomic particles are not found in the nucleus? Well, think back to our picture. That'd be the electrons, the ones that are out there. The mass of the atom is in the nucleus. What subatomic particles determine mass? That'd be protons and neutrons. There are protons and neutrons. Subatomic particles you expect to find at energy levels outside the nucleus, that'd be the electrons. The subatomic particles in the center would be the protons and the neutrons. Which one is most involved in bonding would be the ones on the outside. And the ones on the outside out in here, those are the electrons. All right, so now I'm going to continue on with this section, and then I'm going to stop this video and start the next one. So the element symbol for lithium is Li. You know that just by looking at your periodic table. The atomic number of lithium, you have to look on here to see, it is 3. The mass number is given right here. That's the mass number, 7. It's also on the table, but on the test, you'll go with the mass number that I have listed on this table because the mass can change. Remember, isotopes. Doesn't have to be what on the periodic table, this periodic table, the number that's given for mass is the average mass. But on this test, it'll be the specific mass of that particular isotope. Okay, the atomic number is the same thing as the number of protons. So that means that's 3. There is no charge, so the electrons and protons are equal. So that's 3. And the neutrons, protons and neutrons equals mass. Protons plus neutrons equals mass. So we know the protons are 3 and the mass is 7, so the neutrons have to be 4. Down here, magnesium's atomic number is 12. Just look on the periodic table to find that. Magnesium 12. Right there, 12. And the mass number of magnesium is the protons plus the neutrons, so we have 13 neutrons. We know the protons are 12 because the atomic number is 12, so the mass is 25. Then when you do the hyphen notation, you write the name of the element followed by the mass. Okay. I'm going to skip this and do this part and then come back to the electron configuration. All right, so the element symbol's in the atomic number 7. We know the hyphen notation says nitrogen 15, so the mass is 15. The protons would be 7 because the atomic number is 7. Down here we said atomic number equals number of protons always, just said that. If the atom's neutral, no charge, the electron's equal to the protons. But if there's a positive charge, you've lost electrons. If there's a negative charge, you've gained electrons. And then I reminded you again, protons plus neutrons equals mass number. So, in this case, we know that our mass number is 15, our protons are 7, so our neutrons will have to be 8, because 7 plus 8 equals 15. The electrons should equal the protons unless there's a charge, but there is a charge. And if there's a negative charge, you've gained electrons, so the charge is negative. So if you've gained electrons, and its charge is 3, that means you've gained 3 electrons. Well, if it's neutral, the electrons equal the protons. So when this didn't have a charge, you would have had 7 electrons. But now that you've gained 3, you get 10. On the next one, you have 14 protons. 14 protons is the element silicon, and you already know that because it tells you here. So you put Si, which is your symbol. The atomic number of silicon we know because it says there's 14 protons here, so that has to be 14. The mass number of silicon is this number right here, so that has to be 29. Neutrons are 15. But we don't have to figure that out. You could if you wanted to, though, because you know 29 is their mass number, and you got 14 protons. So 14 plus something has to equal 29. That would be 15. And the electrons here, we have a positive charge. So if it's positive, you've lost electrons. So you've lost 4. Normally you would have the same as the protons. So normally you'd have 14 electrons in silicon. But if you've lost 4, now you got 10. I might as well throw a word at you. Since those two have the same number of electrons, we say that they are isoelectronic. That's kind of a fancy word that just means having the same number of electrons. All right, I'm going to stop there and continue with video number 2.